Hey everybody, welcome back. In this video, we're going to continue this look at dividing radicals, specifically square roots, and I'm going to teach you how to do something called rationalizing a denominator. Now, before you think this isn't going to be a skill you're really ever going to use past Math 1, you need to think about this because you got to take Math 3, and anytime you're dealing with trigonometry, there's lots of radical denominators. That's why we're kind of covering this in the geometry unit, because it's going to happen. Okay, you're going to get these radicals in your denominator and they're not considered simplified, and we have to fix that. So let's get to work here and see what we can get into. I've got this, oops, wrong screen. Kind of a neat little example here. Typical problem you might run into: square root of 15 divided by the square root of 15 halves. Square root of 15 halves. Now, this is a property. I put this up here, and again, if you're keeping notes on this, this is 1.4, rationalizing a denominator. And the first of all, the key property we're going to need is this. Now, if you can imagine this being 2s, imagine a was 2. Square root of 2 times the square root of 2 is, by the other property, the square root of 2 squared, which would be 2. All right, so basically this is saying if you take a radical and you multiply it by another radical just like it, you get what's inside, radicand. Now we're going to use that to our advantage here to simplify and get rid of these radical denominators. So I'm going to go right to work on this thing, and we're going to simplify the square root of 15 halves. Now we already had a property here that said we could separate this into two different radicals like this. Right, so we got the square root of 15 divided by the square root of 2. This right here is a problem. Okay, so this won't divide into that nicely like that last example we did, and now I'm stuck with something like this, and this is not okay. So, to rationalize the denominator, you're going to multiply this entire fraction by a 1. Okay, but the choice of 1 is always based on what's radical down here. What's causing the problem? Well, the square root of 2 is. And we need to multiply him by another one just like him. Because if we do that, we're going to get 2. That's why I call that the key rule or key property. But we can't just multiply the bottom, because that would violate a serious rule there. So we're allowed to multiply any number by 1 that we want to. So we'll multiply this guy by 1. And our choice of 1 is always based on the denominator. So what's radical in the denominator? All right, so this is going to give me the square root of 30 divided by 2. Okay, now we could possibly simplify some more in a lot of cases, so we need to look at that 30. Now he's 3 times 5 times 2. He doesn't have a perfect square factor in there, so this is actually done. So it's the square root of 30 divided by 2 is the simplified version. Okay, and that's called rationalizing a denominator. Earlier, we ran across this one. We had the square root of 10 divided by square root of 2. And we had a quick trick to that one. We wrote it as a fraction like that, divided that 2 into the 10, and got a 5. Now, we could have rationalized it. I told you in the last example. If we'd wanted to, we could have multiplied by these two, and that would give me the root 20 over 2. Now, square root of 20 isn't simplified because that's a 4 times 5. So that's the square root of 4 times the square root of 5, still all over 2, which is 2 root 5 over 2, and they'll cancel to give you that square root of 5 we got on the last example. A lot harder than just dividing that 2 right in. Like I said, by far that was a quicker way to do it. But that's what they call rationalizing a denominator. Okay. See if I got another example. I don't. But I do want to show you something that could be a helpful trick for you. Okay, so what we just found was this is equal to, I do want to show you one more thing in this video. This is equal to, what did we say, the square root of 30 over 2. So let's put that fraction up there, and we'll put a radical in it. So we got the square root of 30, and that's divided by 2. All right, so this is not a foolproof method because you could have it simplified incorrectly and still have the same value. But one way to kind of convince yourself that you're doing something right here is find out what the value of the square root of 15 halves is. So I'm going to put my 15 in there and divide it by 2. Keep it inside the radical, and I'm going to hit enter. And you'll get a decimal approximation like that. Now take your new version, and I'm going to divide that by, notice I came outside the radical with that division. And I'm going to divide that by 2, and you get exactly the same approximation, and that's an indication that you're doing this right. Anyway, so that's how you simplify a radical, and I hope this video was helpful for you. In the next video, we're going to add, subtract some radicals, and that'll pretty much wrap up what we need to get through this geometry. So I'll see you in the next video.